What is the derivative of f?
2.
Good. Find f inverse.
X equals 2y minus 3, which will equal y equals x over 2 plus 3.
So f inverse equals x plus 3 over 2. Does everyone agree? Or you could write that as 1/2 x plus 2/3. Oh, you're right. Thank you. What is the derivative of f inverse? To what? The derivative would be 1/2. Did you do low d high minus high d low? If you did, the derivative of the bottom would be 0, and so that whole term would go away when you do high d low.
Yeah, how do we know if we do right d left over just do the outside terms versus the inside?
If there's something on the inside, you need to do an inside function. If there is a product, you need to do a product. Read the problem. If you say times, you need to do a product rule. If you say of, you need to do a chain rule. Like natural log of 2x plus 3 is a chain rule. Cosine of x times sine of x is a product rule.
So what if it was like x thingy?
Do what? X what?
Parentheses something. Close parentheses.
X times. Now, the right may need a chain rule as well, if it has something inside it. Okay, compare the two derivatives. What do you notice about them?
It's the reciprocal.
Remember, a derivative is a slope, right? Isn't slope change in y over change in x? Would it make sense that if you switch the x's and y's, those would switch to be change in x over change in y? Does it make sense they would be reciprocals? Seems reasonable, right? So I have asked you to graph f and f inverse in the line y equals x on the graph. What was the original? Okay, so this is all right, and then the other function 3 over 2 was the y-intercept, is that right? And the slope was so down. I was gonna go down and left. I don't know why. I could go the other way. And F1. Then it asked me to graph the line y equals x. This one dotted.
Yeah, I was right.
Okay, those are a reflection over the line y equals x. One thing I do want to point out, the slope on a line is the same all the way across, correct? However, if we were getting technical and maybe the slope were to change on something other than a line, would you agree that the corresponding points have the x's and y's switch? For example, the point 0, -3 would correspond to the point -3, 0. The slopes at those 2 points will be reciprocals for when the slope changes. So we're going to look at that today, and we're going to learn how to find the derivative of an inverse function. So there is a formula for it, one that you will want to memorize, and then there's also another way that we're going to look at it for those of you who aren't as much formula users. If f and g are inverse functions, then f of g of x is x. In fact, that's how inverse functions are defined. They undo each other, right? So if I wanted to take the derivative of that, would you agree it would involve a chain rule?
Yes.
Equals 1? Because the derivative of x is just 1. So g prime of x is 1 over f prime of g of x. So if I know the derivative of f, I can use it to help me find the derivative of its inverse, g. However, it's not just 1 over f prime of x. What is g of x another name for? Or f of x? A y value, right? So g prime of x is equivalent to 1 over f prime at the y value because all the x's and y's are switched. So this is a formula. It works great, although a lot of people have a hard time switching the x's and y's in their head. So I have another way to do it that's a table way.
Wait, how'd you switch it?
You mean from here to here?
So that is y.
I just said, hey, by the way, g of x is the y value on g.
So it's the inverse?
So that's how you find the derivative of the inverse. Again, a lot of people struggle with the whole x and y switching thing. So I'm going to show you another way to do it with a table. If you like it, put it on a note card and remember it. Your teacher next year may have no idea what in the world you're doing with the table. So I would write it down if you like it. The formula is the way a textbook will teach it. So I just want to, I'll show you both. You can make your decision. Back there by that. Yes. So the formula, if f and g are inverses, then the derivative of g, which is the inverse of f, is 1 over f prime of y. And you could even say the derivative of f inverse of x is 1 over f prime at the y value. So, some key things to remember about f inverse and f. 1, to find f inverse, you switch x and y. If the problem is the bell ringer and you want to know the derivative, do what we did on the bell ringer. Switch x and y, solve for y, find the derivative. It was pretty easy to do. There will be some problems that you can't do that, though. So we do need to know that the slopes of f and f inverse are reciprocals, but they are reciprocals at the corresponding points, not at the same x value, because the x and y switch. Right, Devin? You're trying to sleep on me again. All right, so let's look at example number 1. This table, draw it in your notes. You may like it. If you do, you will want to use it. This table, a lot of students really find helpful for inverse derivatives. Caution. A lot of students find this really helpful while they learn it, and they don't write it in a special place where they can find it, and by the time they get to the AP exam, they don't remember how to do it. So be careful. If you want to use the table, it needs to make a very important place in your notes, maybe somewhere by your calculus helper or something like that. I don't know, but if you want to use it, if you decide you like it and you can make that decision in a few minutes, then you'll want to put it in a place where you can find it next year. It is not the way I learned it. I saw it at a conference sometime. Okay, so example number 1. If f of 2 is 7 and f prime of 2 is 8, then first of all, what is f inverse of 7? Well, you tell me, what is f inverse of 7? How do you know? Because you switch x and y, that's what f inverse does. Then the derivative of f inverse at 7 would be what? What do you know about the derivatives of inverse functions?
Negative reciprocals.
They are not negative reciprocals, they're just reciprocals.
8.
1 over 8. If this is a problem in the AP exam, it's a really easy problem because they don't really give you information to mess up. But I will show you how they can. Yes. The derivative at 2 of f is 8. Now, let me show you how the table works. We ready? On f, what is the x value we're looking at? 2. And what's the y value? And what's the slope?
The derivative.
Inverses, what do you do with x and y? You flip the x and y, and the slope is the reciprocal.
Oh.
So you see how that table works, how it can help you organize your thoughts. Now, it may not seem useful to you yet, but I'll show you a real AP problem, and they throw in some distractors. This problem had no distractors in it. It only had one derivative sitting there, so you didn't have anything you could really mess up. But I will show you how they can get a little trickier. Any questions about the switching x and y and the flipping the slope? Let's look at another example. If f and f inverse are both differentiable functions for all x, with f of 3 equals 5 and f prime of 3 equals 7, what is a tangent line equation for f inverse of x at 5? What do I need for a tangent line?
An x and y and a slope.
X, y, and a slope. And do you agree I want the x to be 5 on my f inverse? That's what I want.
So that means your y will be 5. 3 for x.
Okay, you see how they're backtracking? They said, okay, if y is 5, that means my x is 3 because they told me f of 3 equaled 5. But that also means the y value on f inverse is 3.
And the other one's 7 and 1 7.
See how the table's so useful? So what is the tangent line?
Oh, you got the tangent line of the reciprocal.
So you wanted the tangent line to f inverse at x equals 5. I'm going to stall for a moment and let y'all process and write and all those things. How many of you feel like you could have done that problem without the table? Okay. How many of you feel like the table really, really helped on that problem? So if you're raising your hand now, you need that table in your notes somewhere special because your teacher next year may or may not know the table thing. It's not a It's not a calculus rule or anything. It's just a way to organize switching x and y and changing the slope to the reciprocal. So if you like it, write it down. If you still use your note cards, you might put it on a note card. If you don't, you might tape something to your calculus helper or something like that. Tape it over the unit circle part. You don't need that. You know that already, right?
Yeah. That's some trash.
It's in your head. You need it, but it's just in your head already.
I won't go that far.
Okay, any questions on that one? All right. If g of x is the inverse of f of x, use the table to find g prime of 2. This is not the table that I made up. This is a table they gave me. If I want to use the table, what do I have to do? I have to draw it, right? So, and if you are ever working an AP problem, they will never give you this. That's something that you have to come up with from your head. If you like it, memorize it, use it. So, my one big word of caution to you is forgetting it. I'll show you how to do this if you've forgotten the table as well. So, x, y, and m. Where am I looking for the derivative? And this is actually g, right? F prime is, or F inverse is g. F prime. F inverse is g. So F inverse, or g, I'm looking for the derivative at 2. Everyone agree? That's my question. What is the derivative of g at 2?
Put 2 on the wall.
Okay, and what is the x value on f when y is 2? -3. And what is the derivative? So what is the derivative? Right. So the answer to this question is 1/5. Now let me show you the formula, which is the thing that, yes. Okay, so the 2 came from the question. Find g prime of 2, which is the x value on, and this, we could call this g, right? It's the inverse of f. If that's the x value on the inverse, it's the y value on the original. And so then I go up to my table and find when 2 is the y value. The x value is 3, -3. And then the slope is 5. Okay, the formula. The derivative of f inverse. Because some of you are more formula-driven users. Is 1 over f prime at the y value, correct? And so f prime at y. Well, what is the y value that we're talking about? Right, it's this -3, right? I would need to know the y value for g, which is the inverse. So I would need to know that this is -3. And so I would do 1 over f prime at -3, which is 1 over 8. So that's how the formula works. Do what? Oh, sorry, it's not 8, it's 5. My bad. F prime of -3 is what? Okay. It's not different answers. Sorry about that. So that's how the formula works. That's how the table works. I imagine that this is a very polarizing thing, and some of you have decided, I love the table, some of you love the formula. I don't care how you do it. Do it right. Either way. Do what? As long as you do it correctly, it's wonderful. But again, I especially caution you, since I won't be here next year, that your teacher next year may not use the table. It's kind of a strange thought process. It's not something that's in a textbook. So store it in your somewhere in your stuff. Okay. I now want to look at finding, whoops, I think I skipped a slide. Did I skip a slide? Maybe not. Y prime if I have cosine inverse of x squared. There are two ways to do it. We could use an inverse thought process, or we could do implicit differentiation. For this one, I'm going to do implicit differentiation. Then I'm going to show you a formula, and then we'll use a formula from then on. But I do want to show you, if you get on the AP exam and you've forgotten an inverse derivative, you could get your way through it implicitly. What I mean by that is, could I rewrite this as what?
Y equals negative.
No. Get rid of cosine inverse. How do you get rid of cosine inverse?
Cosine.
Cosine of both sides. Would you agree? Cosine of y would equal x squared. That's what cosine inverse means. Can I take that derivative implicitly?
Yes. Negatives. Or sine. Negatives.
Negative sine of y times what? Oh, sorry, 2x. You're right. 2x over negative sine of y. Nothing wrong with it. It's a wonderful way to work, especially if you're on open response and you get stuck. So we could always do an inverse implicitly. But there is a formula, and I'm going to prove the formula to you by doing the same thing here. Would you agree sine of y would equal x? Take the derivative implicitly. So you get cosine of y times y prime equals 1. So y prime equals 1 over cosine of y. Look at your calculus helper. Is 1 over cosine of y what it has down for the derivative of sine inverse?
No.
No. Well, we need to figure out how they get there, right? So let's draw a picture. I know the sine of y equals x. Do you agree that means y is an angle? And that means the opposite side is x and the hypotenuse is 1. Sine is x over 1. Opposite over hypotenuse. Everyone agree with that? Could I find a third side?
Yep. Pythagorean theorem.
Pythagorean theorem. 1 squared minus x squared, square rooted. Everyone agree with that? What is the cosine of y? Adjacent over hypotenuse. Now look at your formulas. What is the derivative of sine inverse?
U prime over U.
Okay, so they have some u's in there, but if those u's were x's, would this be correct?
Yes.
So that's how you find the derivative of sine inverse. Use the formula, right? You can memorize it, use it. If you ever forget it, know that there is a way to create it. See your calculus helper for the rest of the trig inverse derivatives. Tomorrow we'll learn the why behind the e in natural log. And then we'll also learn one other thing. These two homework assignments, they are both very short, and they both involve just practicing derivatives. are your homework for tonight. There are 19 of them. You will need to know that velocity is the derivative of position. These are not AP problems, these are textbook problems, generally easier. Make sure anytime we're working out of the calculus book that you do the exercises, not the what is it called before those, the practice, or don't do that. Do the real problems. 2 through 10 even and 28 on 175, and 2 through 26 even on 183. Tomorrow we're going to learn the why behind logarithms, and we're also going to learn a nice little rule called the L'Hopital's rule. You will like it. It's a shortcut for limits. So we'll learn that tomorrow. Also, don't forget to, at maybe a problem a night, look at one of those AP problems every night if you can. We will get an official assignment next week, but those can be intense. So start picking at them if you can. They are due before the test. The test is next week. Today is the 3rd of March.